Hi, welcome on this demo video showing you the very last tools I developed for Vicon Blade. First of all, I'd like to say thank you to Brian Rush from House of Moves and Andy Ray from Vicon UK for giving me the opportunity to create those tools. Second thing, I'd like to apologize in advance for my horrible French accent. I hope you understand everything I would say. Okay, so let's start with a small example to see how Bezier spline work in Blade, and then we'll go on a more complex example showing you how to use it. So let's start Blade. Okay, and open a simple scene I prepared. Here we go. Open the tools I created and start. So the Bezier tools are part of an existing panel I scripted a few months ago to be able to create virtual points. For those of you who knew Vicon IQ, that should ring a bell. I'll show you later how it works, but first let's focus on 3D curves. So spline needs actually 4 coordinates to work. Start and end points and 2 tangents. So I can create my first Bezier spline and make it work in real time. For that I select the points in that order. So start tangent, end tangent and end. Okay. Give a name to my curve. Let's call it curve. Give a color to it. Pink, for example, and create it. Okay, so my first curve is not very nice, as you can see, so we'll try to improve it a little bit. So for that I check the real-time editing so I can see my changes in real time. So first of all I will increase the resolution like this. Okay, I can change the color, put in yellow for example, and of course I can move the coordinate marker in real time like this. Okay, so of course I can do what I want. So as you can see, it moves, everything is in real time. I don't need to recalculate some stuff every time I move the markers. Okay, so I guess it's a better example to show curves in Blade. Okay, so now let's have a look on a practical example to see how this curve can simulate a spine and neck motions. So I load a scene I prepared, which is a regular marker set, a range of motion. Okay. So back on virtual points a little bit. So the virtual points are markers who are simulated by real captured markers but don't exist during the shoot. So let's create my first virtual point to see how it works. So for that I choose 3 markers, or 2, 3 or more, but in that example I will pick 3 markers to create a system which will be oriented in time like this. Give a name to my virtual point like point. Give a color to it like green and create it. So here I have a template that simulate the position of the virtual points. I can still edit that template if I want. I can rename it like my point, for example. Can rename the virtual point. I can still change the color. I can change the type, going from relative to absolute coordinates. And of course, I can change the coordinates like this. Okay, like this, for example. Okay, so I can change the color, position, name, position in list too, and save all those settings in a file for later. Once they are actually calculated, virtual markers can be sourced for other virtual markers as well. That's why order in the list is very important. So let's finish my work. So create other virtual points and create the spine. So back to 0, 0, 0. Call it end. You'll understand why. Okay. Create another one with the same coordinates system. Put it in green. Call it end T stand for end tangent. Change its type. Going a bit down. Okay. Create another one which would be the center of gravity of the hips. So call it start. Choose another color, blue for example. Okay, here it is. And for the last one I will show you a special tool I developed for snapping virtual points to existing coordinates. So for that I calculate all those markers, which means that they have actual position under the character. Select this one and create a temporary marker. I will call temp. Parent it to the last selected and give it a pre-translation. Okay, now create my last virtual point. So again, a system of 3. Change the color, call it start T, stand for start tangent. Create virtual. So for the moment it's here, but I will snap to that point and snap. Now my temp marker is useless, so I can erase it and calculate all the virtual point position. Okay, so now I can remove the template virtual points because I don't need them anymore. And see that virtual markers are dependent to body parts. Okay, so the last thing to do is to create a spine, for example, with let's say 6 markers. Like before, select the coordinates and create the spine for the whole time. So you have a progress bar here to show you the progress. Okay, it's done, so I can hide the coordinates and see my result. So I have nice result. Okay. Okay, all this work is good but very long to do, as you can see, so that's why I created pipeline operation and automation process to speed up the process a lot. So let's reload the scene and redo all this but a little bit more quicker. So open basic again. Let's find a good pose. For example, this one, and run my pipeline operation to automatically create those spine. So here it is. Create a preview of the spine. So again, progress bar. Okay, so got a nice preview of what I wanted. So as you can see, I created a spine for the neck as well, because it could be used for the neck as well. So if I'm not happy with the position of the default position, I can always edit it. So open my panel again and edit the position of my spine. For example, like this and like this. I can hide the coordinates to double check it's okay, and of course update position for the whole time. That's what I'm doing here. Okay, so pretty nice results as well. So once I've done that, of course I will save the coordinates in a file so I can use them later without having all that stuff to do. So for this, just run the rest of my pipeline and it will save the coordinates for me. So run the pipeline, so create references, load automatically virtual points, and snap them automatically to the coordinates as specified, and propose to save them in a file like this one, for example. Okay, so now the coordinates of my spine are saved in a text file, so I can use it whatever I want, and I can then batch a lot of things and speed up the process a lot. So to finish, let's have a look of some result done with the mix of all those tools on complex movement. I choose modern dense movement to show you nice deformation of the spine. So let's open the first one. Okay, hide this panel. So a nice S spine, S-shaped spine. So here are the results. So we can focus on special poses to double check this. So let's hide the markers and see the results. Okay, let's focus on another part of the animation to see a nice and smooth deformation like this of the spine. I'm gonna frame it. Okay, so as you can see, the deformation is nicely separated on the different bones. Okay, let's open another file, which is Oriental Dance, which is the best to see spine movement. So I'm gonna play this in real time so you can see, it would be better. So again, a spine with 6 bones on it. Okay, so as a conclusion, all those tools can be used, of course, to have a perfect simulation of usual tricky parts like neck, spine and shoulders, and I guess it could be used for many other cases, but it's up to you to find them. So thank you for watching and see you next time.